Hey everybody, we're back here looking at ChatGPT again. I've been having a lot of fun trying to ask some questions. And again, if I've mentioned in a couple of other past videos, there's a lot of questions that come up and people make certain statements. And I thought it'd be interesting, rather than me just answer it with what I know from my own education, but just to go ahead and ask ChatGPT. One of the things I'm always it always comes up when we get into these order of operations problems. I mean mixed operations, where you've got multiplication mixed with addition, subtraction, perhaps division in there. You got a long expression where you've got mixed operations. You're not just adding and subtracting, in other words. And one of the things that always comes up is, well, the order of operations doesn't apply here because this isn't algebra. It only applies in algebra. And I've heard that from so many people. So I thought, hey, let's ask ChatGPT and see what ChatGPT says. All right, we're just going to use the free version here again. No, it says no. Does the order of operations convention apply only to algebra? No, the order of operations convention. Also, we know that through PEMDAS and BODMAS, but I will say, a lot of people will come back to me and say, well, I was never taught PEMDAS, I was never taught BODMAS. Keep in mind, those are just acronyms. That's not the order of operations. The order of operations was taught, centuries before we had PEMDAS or BODMAS. Those are just acronyms. They're memorization tools. They're actually lousy memorization tools, in my opinion. But the order of operation convention applies to all areas of mathematics, not just algebra. It is a general rule that helps ensure consistency and clarity in solving mathematical expressions across various fields, whether you're working with arithmetic, algebra, or even advanced topics such as calculus, geometry, and beyond, like Bed, Bath, and Beyond. Remember that? The order of operations convention is relevant in arithmetic. Even in simple arithmetic, the order of operations is important. For example, in an expression like 3 plus 5 times 2, here we go. 3 plus 5 times 2. I'm not sure why that's blacked out. The multiplication is done first. 5 times 2 is 10, and then the addition. 3 plus 10 is 13. So keep that in mind. When you have 3 plus 5 times 2, you do the multiplication first. Now, in algebra, the order of operations is crucial for simplifying expressions, solving equations, and working with formulas. For example, in the expression 2x plus 3 times the quantity x plus 1, parentheses are handled first, then multiplication, and finally addition. Yeah, keep in mind, you solve parentheses first, then your exponents, or orders if you're familiar with BODMAS, and then multiplication and addition. Calculus. The order of operations is also applied in calculus when simplifying expressions involving derivatives, integrals, or limits. For example, when differentiating an expression like f of x equals 3x squared plus 2x plus, and then, of course, it's kind of blocked out. I think they're maybe inserting a graphic here. The powers are handled before the multiplication or addition, and differentiation rules are followed systematically. So exactly right. You first would look for parentheses. Okay, we don't have them in this problem with this function, but we do have powers. Powers, or they're also known as exponents. Those are handled ahead of multiplication, and then you go on to addition, and so on. Trigonometry. In trigonometry, operations involving trigonometric functions must also follow the order of operations. For example, in expressions like sine of x plus cosine x times 2, the multiplication of the cosine function is done before the addition of the sine function according to the order of operations. So hopefully this is making some sense. Geometry. In geometry, especially when dealing with formulas for area, perimeter, or volume, the order of operations is used to evaluate expressions correctly. For instance, the area of a rectangle is calculated as length times width, where multiplication must be done before any additional operations like adding a constant for a perimeter. So why the order of operations matters. So this is really important because this comes up a lot. Without a clear rule for the order in which operations should be performed, different people might interpret the same mathematical expression in different ways, leading to different results. And I see that all the time. Well, in my book, I do it this way. In my way, I do it this way. Well, that's not how mathematics works. Mathematics is not subjective. It's not a choose your own adventure book. So by following PEMDAS BODMAS, which again, those are just the acronyms. Please don't get confused. And those are just acronyms for the order of operations. But parentheses, exponents, then multiplication, division, left to right. That's an important one. Multiplication and division have equal precedence, and they're solved left to right. Division is nothing more than multiplying by a reciprocal. And now addition and subtraction. Yeah, left to right. Honestly, addition and subtraction can be done in any order. I can say 3 minus 5 is negative 2, right? Minus 5 plus 3 is also negative 2. It doesn't matter the order that I add and subtract with those two numbers. I still get the same answer. But yeah, by following that, you ensure that people get the same answers. I mean, can you imagine how would we ever get rockets to the moon? I mean, there may be some people out there who believe it was all done in a film studio. And sorry, I can't help you guys. But, how could we get anything done if people in the world all did math differently? It makes no sense. So the order of operations is essential across all branches of mathematics, not just algebra, to ensure consistency and correctness when solving mathematical problems. So, hey, I hope that's been helpful. I hope that explanation has been helpful. So the next time you hear somebody say, oh, that only applies in algebra, this is simple math. And I hear that one a lot too. This is simple math. This is easy math. This isn't algebra. You just go left to right. That's incorrect. And I also hear things like, well, this is verbal math and not, no, when we're looking at a problem and it's written down on a piece of paper or on a screen and it's got, 5 plus 3 times 2 equals what? That's not verbal math. That is a problem written out. That's an expression written out with an equal sign on the end, which basically makes it an equation at that point. Equality. Yeah. So anyhow, that's not true. This applies to all branches of mathematics. So just keep that in mind. But hopefully this explanation has been helpful. If you get into one of these online discussions, hopefully this will help you out. And I look forward to seeing everybody in the next video. Have a great day.